Welcome back to 100 Sleepy Facts, our cozy corner for fascinating stories that gently guide you into relaxation. In today's episode, we're diving into the mysterious world of Archaeopteryx, the legendary creature that bridges dinosaurs and birds. A true symbol of evolution in action, it carries both reptilian and avian features in one incredible body. But here's a question for you. Do you really believe that birds today are actually descendants of dinosaurs? If that idea surprises you, you're definitely in the right place. Before we begin, don't forget to subscribe to the channel and leave a comment below sharing your thoughts. We'd love to hear what you think about this fascinating topic. Now, let's slowly explore the ancient world together. Title: 100 Facts about Archaeopteryx. Full documentary script introduction. Welcome, explorers of ancient worlds, to a profound journey into the past. Today, we embark on a deep dive, uncovering the mysteries of one of the most captivating prehistoric creatures ever unearthed, Archaeopteryx. Heralded by many as the first bird, this magnificent proto-avian stands as a monumental landmark, representing a pivotal, revolutionary stride in the evolutionary saga that transformed formidable dinosaurs into the agile, feathered aviators we marvel at today. In this comprehensive, documentary-style script, we will meticulously unravel 100 detailed facts, each a piece of a grander puzzle, illuminating every facet of Archaeopteryx, from its intricate anatomy and elusive behavior to its ancient habitat and unparalleled scientific significance. Prepare to witness a creature that bridges two worlds, a true icon of evolutionary change. Fact 1. The epical discovery in its Jurassic world. Our journey begins not with the creature itself, but with its dramatic entrance onto the scientific stage. Archaeopteryx was first discovered in the meticulously fine-grained limestone quarries of Solnhofen, Germany, during the 1860s, a discovery that sent ripples through the scientific community, coinciding remarkably with the publication of Charles Darwin's On the Origin of Species. This magnificent creature thrived during the late Jurassic period, a lush and dynamic era approximately 150 million years ago, in what we now recognize as the sun-drenched, shallow sea archipelago of Europe. Imagine a landscape dotted with small islands, bordered by coral reefs, where pterosaurs patrolled the skies and marine reptiles swam beneath the surface. It was within this vibrant ecosystem that Archaeopteryx carved out its existence, a world teeming with life, yet vastly different from our own. Its initial fossil finds immediately revealed a breathtaking mosaic of traits, a seamless blend of reptilian ruggedness and avian elegance, possessing the sharp teeth and long, bony tail characteristic of its dinosaurian ancestors, yet undeniably equipped with fully developed, aerodynamic feathers forming sophisticated wings. These profoundly mixed features solidified its status as arguably the most critical and celebrated transitional fossil ever brought to light, offering an undeniable, tangible link between two major branches of the tree of life. Fact 2. The revolutionary design of its feathers. Perhaps the most striking and evolutionarily significant feature of Archaeopteryx is its impeccably preserved plumage. Unlike the simpler, down-like feathers found on many other feathered dinosaurs, Archaeopteryx proudly displayed asymmetrical flight feathers on its wings and tail, a crucial detail that mirrors the feather structure of modern flying birds. These asymmetrical veins are specifically engineered to generate lift and minimize drag during flight, indicating a clear adaptation for aerodynamic function. The presence of these highly specialized feathers immediately suggested that Archaeopteryx was not merely a feathered ground dweller, but an active participant in the aerial environment. The remarkable detail of these fossilized feathers provides invaluable clues to the very genesis of avian flight, allowing paleontologists to trace the sophisticated mechanics of flight-enabling structures directly back to this pivotal Jurassic creature. It wasn't just any feather. It was a feather purpose-built for the skies. Fact 3. Echoes of its dinosaurian past, reptilian remnants. Despite its advanced feathers, Archaeopteryx retained several unambiguous reptilian characteristics that firmly anchor it within its dinosaurian lineage. Most notably, its jaws were lined with small, sharp, conical teeth, a stark contrast to the toothless beaks of virtually all modern birds. These teeth suggest a diet of small prey, such as insects, lizards, or possibly even fish, providing a direct link to its carnivorous theropod ancestors. Furthermore, unlike the short, fused tails of modern birds, Archaeopteryx possessed a long, bony tail, extending well beyond its body, comprised of numerous individual vertebrae. This tail, likely adorned with feathers, would have provided crucial balance, acting as a dynamic counterbalance or even a rudder during aerial maneuvers, a feature reminiscent of many small, agile dinosaurs. Finally, its wings were equipped with 3 distinct, clawed fingers at the end of each forelimb. These claws were not just vestigial, they were fully functional, indicating a capability for grasping, climbing, or perhaps even manipulating objects, further highlighting its dual existence between a terrestrial and an arboreal lifestyle. Fact 4. The blueprint for flight, avian innovations. While carrying dinosaurian baggage, Archaeopteryx also showcased groundbreaking avian adaptations essential for flight. Its bones, though not as extensively hollow as those of modern birds, were notably lightweight and partially pneumatized, meaning they contained air sacs connected to the respiratory system. This reduction in skeletal density was a critical evolutionary step, significantly decreasing body weight, a paramount requirement for achieving lift and sustained flight. Even more telling is the presence of a well-developed furcula, or wishbone, formed from the fusion of its 2 clavicles. In modern birds, the furcula acts as a spring during the flight stroke, strengthening the chest and aiding in the powerful downbeat of the wings. While Archaeopteryx's furcula wasn't as robust as that of modern birds, its existence undeniably points towards the evolutionary path leading to the sophisticated flight mechanisms we observe today. These skeletal modifications reveal a creature actively transitioning, shedding the weight of its ancestors while adopting the structural efficiencies of future flyers. Fact 5. The enduring mystery of its flight capabilities. One of the most intensely debated questions surrounding Archaeopteryx is the precise nature of its flight. Was it capable of true, powered flight, actively flapping its wings to generate thrust and lift? Or was it primarily a glider, launching itself from elevated perches and soaring between trees? The evidence is intriguing but complex. Its asymmetrical flight feathers strongly suggest aerodynamic efficiency, a hallmark of active flyers. However, the skeletal structure tells a slightly different story. Archaeopteryx lacked a deeply keeled sternum, breastbone, which in modern birds provides a large surface area for the attachment of powerful flight muscles. This anatomical detail leads many paleontologists to argue that its muscle power for flight was likely limited. This fuels the trees-down versus ground-up theories of avian flight evolution, with Archaeopteryx often positioned as a prime candidate for the trees-down hypothesis, a creature that might have climbed trees with its clawed fingers and then glided down, eventually developing stronger flapping capabilities. The debate continues, making every new fossil discovery a potential game-changer in understanding the origins of avian aviation. Fact 6. Life in the Jurassic Archipelago. To truly understand Archaeopteryx, we must envision its home, the stunning, sun-drenched lagoon environment of late Jurassic Bavaria, approximately 150 million years ago. This region, now landlocked Germany, was then a tropical archipelago of small, low-lying islands separated by warm, shallow seas. The exceptional preservation of Archaeopteryx fossils, alongside countless other marine and terrestrial species, is due to the unique anoxic, oxygen-depleted, conditions at the bottom of these lagoons, which prevented scavengers and decomposition. This allowed for the exquisite imprints of delicate structures like feathers to be preserved. Archaeopteryx likely inhabited these islands, perhaps perching in Araucaria or cycad trees, or navigating the dense coastal vegetation. Its world was shared with an incredible array of life, from giant marine crocodiles and ammonites in the water to various pterosaurs soaring overhead and small, agile dinosaurs scurrying on land. This diverse ecosystem offered both challenges and opportunities, shaping its evolutionary path and influencing its behavior as a predator, climber, and potential flyer. Fact 7. The diet of a protobird, what Archaeopteryx ate. With its sharp, conical teeth, a decidedly reptilian trait, Archaeopteryx was undoubtedly a predator, but likely of smaller fare. Scientists infer that its diet primarily consisted of insects, such as dragonflies and beetles, which were abundant in the warm, humid Jurassic environment. It may also have supplemented its diet with small lizards, frogs, or even juvenile fish from the shallow lagoons, ambushing them from a perch or snatching them with its agile forelimbs. Its relatively small size, comparable to a modern-day magpie or crow, suggests that larger prey would have been out of reach. The presence of teeth, rather than a specialized beak, indicates a more generalist carnivorous approach compared to the highly adapted feeding strategies of many modern birds. Its hunting style would have blended the stealth of a tree-dwelling reptile with the agility offered by its nascent flight capabilities, making it a formidable, albeit small, hunter in its ancient ecosystem. Fact 8. A glimpse into its living appearance and size. Imagine a creature roughly the size of a modern crow or magpie, with a body length ranging from about 1.5 to 2 feet, approximately 45 to 60 centimeters, including its long tail. Its wingspan would have been similar, around 1.5 feet. In life, Archaeopteryx would have presented a truly unique silhouette, a slender, bipedal animal, perhaps with iridescent or mottled plumage, perching or scrambling through the Jurassic vegetation. Its head would have been relatively small, featuring sharp, lizard-like eyes and that distinctive, toothed grin. The long, feathered tail would have streamed behind it, providing not just balance, but potentially a display feature. While its exact coloration remains a subject of scientific speculation, though some melanosome studies offer tantalizing hints of dark, possibly iridescent, feathers, reconstructions often depict it with earthy tones, allowing it to blend into its subtropical island environment. It was a creature of elegant proportions, perfectly adapted to its transitional existence, a living paradox of form and function. Fact 9. The quintessential transitional fossil. Archaeopteryx holds a truly unparalleled position in the annals of paleontology as the quintessential transitional fossil. Its existence provides unequivocal evidence for evolution, beautifully illustrating how life forms can possess a mosaic of features from both ancestral and descendant groups. For scientists, it's not just a missing link, it's a found link, demonstrating the gradual, incremental changes over vast geological timescales. It profoundly supports the theory that birds are direct descendants of dinosaurs, specifically small, feathered theropods. Before Archaeopteryx, the evolutionary connection between reptiles and birds was largely theoretical. With its discovery, the abstract became concrete. A creature with dinosaurian teeth and tail, yet undeniable bird-like wings and feathers. This unique blend offers a tangible snapshot of evolutionary change and progress, making it a cornerstone in understanding the diversification of life and a powerful rebuttal to creationist arguments against evolution. Fact 10. The Many Faces of Archaeopteryx, a chronicle of specimens. Remarkably, our understanding of Archaeopteryx isn't based on a single, isolated find, but on a series of extraordinary discoveries. To date, around a dozen specimens, along with a solitary feather impression, have been unearthed, primarily from the Solnhofen quarries. Each new specimen, though broadly similar, has brought its own unique details to light, collectively building a more complete picture of this ancient bird dinosaur. The very first discovered, known as the London specimen, showed a skeleton with clear feather impressions. The Berlin specimen, discovered later, is considered one of the most beautiful and complete, revealing an almost perfect skeleton with stunning feather details. Other finds, like the Maxburg specimen or the Thermopolis specimen, have contributed crucial anatomical data, some showing a more robust furcula or clearer foot morphology. The continued discovery and meticulous study of these individual fossils underscore the dynamic and ongoing nature of paleontological research, where each new piece of evidence refines and occasionally challenges our existing theories about Archaeopteryx and the evolution of flight. Fact 11. Pinpointing its place, the scientific classification. In the intricate family tree of life, Archaeopteryx occupies a fascinating and at times contentious branch. Initially classified solely as a bird, modern phylogenetic analysis places it firmly within the group Aviali. a clade that includes birds and their closest extinct relatives. More specifically, it is considered a non-avian theropod dinosaur that is more closely related to modern birds than to other non-avian dinosaurs. This classification highlights the ongoing scientific refinement of understanding the bird-dinosaur link. It underscores that birds aren't just like dinosaurs. They are dinosaurs, specifically a surviving lineage of theropods. Archaeopteryx sits at the very base of this avian lineage, making it a critical reference point for understanding what truly defines a bird in evolutionary terms. Its taxonomic placement continues to evolve slightly with new discoveries and analytical methods, but its fundamental role as a bridge between the Mesozoic era's ruling reptiles and the Cenozoic's airborne masters remains undisputed. Fact 12. Archaeopteryx as a stepping stone in flight evolution. While undeniably groundbreaking, Archaeopteryx was not the culmination of avian flight, but rather a spectacular early experiment. Its flight capabilities, whether powered or gliding, were rudimentary compared to the soaring prowess of modern birds. Following Archaeopteryx, the evolutionary trajectory of flight continued to accelerate and diversify. Later bird-like dinosaurs and early birds, such as Confuciusornis and Ichthyornis, began to exhibit more advanced flight adaptations, including fused tailbones, more robust keeled sternums for stronger muscle attachment, and increasingly lighter, more hollow bones. Archaeopteryx provides us with the starting template, a testament to the initial success of feathered wings. It sets the stage for the explosive radiation of avian forms that would eventually conquer every sky and ecological niche across the globe, demonstrating that evolution is a continuous process of innovation and refinement, building upon earlier, foundational successes. Fact 13. Navigating a dangerous world, predators, and survival. Despite its pioneering flight capabilities, life for Archaeopteryx in the late Jurassic was fraught with peril. Its small size made it vulnerable to a host of predators. On land, agile, carnivorous theropod dinosaurs, even smaller ones, would have posed a significant threat. In the air, larger, more powerful pterosaurs, such as Rhamphorhynchus, which also inhabited the Solnhofen lagoons, might have viewed Archaeopteryx as potential prey. The long, bony tail and clawed fingers, while ancestral features, would have served critical defensive and evasive functions, aiding in quick directional changes in flight or agile scrambling through dense foliage to escape danger. Its ability to navigate between arboreal and possibly aerial environments would have been a key survival strategy, allowing it to exploit different niches for foraging and refuge from a relentless gauntlet of Jurassic hunters. Every feather, every claw, and every bone played a role in its daily struggle for existence. Fact 14. Reproductive strategies, echoes of dinosaurian nests. While direct fossil evidence for Archaeopteryx reproduction, such as eggs or nests, remains elusive, scientists can infer its reproductive strategies based on its closest relatives, dinosaurs and modern birds. Like all known dinosaurs and birds, Archaeopteryx almost certainly laid eggs. These eggs would have possessed hard shells, similar to those of its theropod ancestors. It's highly probable that Archaeopteryx engaged in some form of parental care, a common trait observed in many dinosaurs and universally among birds. Small theropods are known to have brooded their eggs, and given the developmental trajectory towards birds, it's reasonable to speculate that Archaeopteryx might have guarded its nest and potentially provided care for its hatchlings. Nesting sites might have been located in sheltered spots among the low-lying vegetation of the Jurassic Islands, or perhaps in rudimentary tree nests, providing some protection from ground predators. Its reproductive life would have been a complex dance of survival, from egg-laying to the rearing of its proto-avian young. Fact 15. The evolutionary journey of feathers. Archaeopteryx stands as a crucial piece in the complex puzzle of feather evolution. The discovery of numerous other feathered dinosaurs in recent decades has dramatically altered our understanding, showing that feathers did not evolve for flight, but much earlier, likely for insulation, display, or even camouflage, among small theropod dinosaurs. Archaeopteryx represents a key stage where these ancestral protofeathers had clearly evolved into sophisticated, asymmetrical flight feathers, perfectly adapted for aerodynamic purposes. Its plumage demonstrates the transition from simpler, hair-like filaments to the complex, barbed, and interlocking structures necessary for flight. Studying Archaeopteryx's feathers allows scientists to trace the morphological changes that occurred as feathers became increasingly specialized for aerial locomotion, illustrating a spectacular example of exaptation, where a trait evolved for one purpose, like insulation, is later co-opted for an entirely new one, like flight. It's a testament to nature's ingenious recycling and repurposing of existing biological structures. Fact 16. Windows to the mind, brain, and sensory acuity. While its brain itself is not preserved, scientists can create endocasts from the fossilized skull, providing remarkable insights into the shape and relative size of Archaeopteryx's brain. These studies suggest that it possessed an enlarged cerebrum and optic lobes, characteristic features found in birds. This indicates sophisticated visual processing capabilities, crucial for navigating complex aerial environments and spotting prey. Its inner ear structure, inferred from fossil evidence, also suggests good hearing, a vital sense for detecting predators and prey. Furthermore, the development of balance and coordination centers in the brain would have been paramount for a creature engaging in flight, even rudimentary. These advanced sensory and neurological adaptations highlight that Archaeopteryx was not merely a clumsy transitional form, but an alert and capable animal, equipped with the cognitive tools necessary to thrive in its challenging Jurassic world and exploit its nascent ability to fly. Fact 17. Ground dweller or airborne. Its terrestrial walk. Before taking to the skies, and even during its aerial phase, Archaeopteryx would have spent a considerable amount of time on the ground. Its leg structure, similar to that of small, bipedal theropod dinosaurs, suggests it was an adept runner or walker. The feet possessed 4 toes, 3 pointing forward and 1 backward, an arrangement known as anisodactyly, common in perching birds but also found in some ground-dwelling theropods. This morphology would have provided good grip for moving across uneven terrain or for perching. While its exact gait remains debated, it was likely an agile creature on land, able to quickly dart and weave through the vegetation, perhaps chasing insects or evading larger predators. Its terrestrial locomotion was a fundamental part of its behavioral repertoire, underscoring that its move to the skies was an addition to its existing capabilities, not a complete replacement of its ground-dwelling heritage. Fact 18. The master climber, evidence for an arboreal lifestyle. Beyond its potential for flight, Archaeopteryx was almost certainly an accomplished climber. The prominent, recurved claws on its 3-fingered hands, combined with similarly well-developed claws on its feet, point strongly to an arboreal, tree-dwelling existence. These claws would have provided excellent grip on tree bark and branches, allowing it to scale trunks and navigate through dense canopy vegetation with ease. An arboreal lifestyle would have offered several advantages: a vantage point for spotting prey or potential threats, a safer roosting location away from ground predators, and, crucially, elevated platforms from which to launch itself into glides or rudimentary flights. This trees-down hypothesis for the origin of flight suggests that climbing was a precursor to aerial locomotion, and Archaeopteryx's anatomy perfectly aligns with this concept, painting a picture of a creature spending much of its life scrambling and perching high above the forest floor. Fact 19. Not a direct ancestor, but a close cousin to modern birds. While Archaeopteryx is often colloquially dubbed the first bird, it's more accurate to view it not as the direct ancestor of all modern birds, but rather as an early, highly successful, and deeply informative close relative or a foundational member of the avian stem group. The evolutionary tree of birds is complex, with many branches and extinct lineages. Archaeopteryx represents a very early branch that diverged from other feathered dinosaurs, developing distinct avian features. It shows us what those very first, fledgling steps towards birdhood looked like. Later avian forms diversified and evolved into the myriad species we see today, but the fundamental innovations seen in Archaeopteryx, asymmetrical flight feathers, a furcula, lightweight bones, laid the groundwork. It's a prime example of an evolutionary success story, a testament to the early innovations that allowed one lineage of dinosaurs to eventually dominate the skies and survive the mass extinction event that claimed its larger, non-avian relatives. Fact 20. unlocking secrets with advanced paleontological techniques. The enduring study of Archaeopteryx isn't just about finding new fossils. It's about employing cutting-edge technology to coax ever more secrets from existing specimens. Traditional fossil preparation involves painstakingly chipping away rock, but modern paleontology utilizes a suite of non-invasive techniques. High-resolution CT scans allow scientists to peer inside the rock without damaging the fossil, revealing hidden bone structures, internal bone density, and even the paths of ancient blood vessels. Synchrotron scans can detect residual chemical signatures, providing clues about original feather coloration through the analysis of melanosomes. Microscopic analysis of feather impressions can reveal details about barbules and feather structure previously invisible. These advanced tools continue to refine our understanding of Archaeopteryx's biology, from its flight muscles to its brain architecture, demonstrating how technological innovation continually redefines what we can learn from ancient, stone-cold evidence. Fact 21. Debunking myths, common misconceptions. Despite its iconic status, Archaeopteryx is often subject to several common misconceptions. Firstly, while frequently called the first bird, this term oversimplifies a complex evolutionary process. It's more accurately described as one of the earliest known bird-like dinosaurs with definitive flight feathers, rather than the sole progenitor of all birds. The definition of bird itself is fluid and debated within paleontology. Secondly, the idea that Archaeopteryx was the only feathered dinosaur is demonstrably false. Decades of discoveries, particularly from China, have revealed a vast array of feathered dinosaurs, many predating Archaeopteryx, showing that feathers were widespread among theropods. Archaeopteryx's unique significance lies in its flight-adapted feathers, not merely the presence of feathers. Correcting these misconceptions allows for a more nuanced and accurate appreciation of its place in the grand narrative of avian evolution, recognizing it as a pivotal, but not singular, player. Fact 22. The miracle of Solnhofen, a window to the Jurassic. The very existence and exquisite preservation of Archaeopteryx are a testament to the unique geological conditions of its burial site, the Solnhofen limestone formation in Bavaria, Germany. This location is a prime example of a Lagerstätte, German for storage place, an exceptionally rare type of fossil deposit where soft tissues and delicate structures, like feathers, are preserved with astounding detail. The environment consisted of shallow, anoxic, oxygen-deficient lagoons cut off from the open sea. When an animal like Archaeopteryx died, its body would often settle into this calm, oxygen-free mud, preventing scavenging and decay. Fine carbonate particles would then rapidly encase the remains, leading to perfect, high-resolution impressions. This geological miracle has provided an unparalleled snapshot of a Jurassic ecosystem, not just for Archaeopteryx, but for thousands of other beautifully preserved organisms, from jellyfish to pterosaurs, offering an invaluable window into a world-long past. Archaeopteryx, often hailed as the first bird, stands as an unparalleled icon in the annals of paleontology, offering scientists critical insights into the grand tapestry of evolution. Living approximately 150 million years ago during the late Jurassic period, in what is now the Solnhofen lagoons of Europe, this remarkable creature occupied a pivotal position in Earth's history, bridging the morphological gap between terrestrial dinosaurs and the first flying avians. What makes Archaeopteryx so extraordinary is its astonishing blend of reptilian and avian characteristics. Its dinosaurian heritage is evident in features such as sharp, conical teeth set in its jaw, a long, bony tail that would have provided counterbalance, and distinct claws on its three-fingered hands, capable of grasping branches or prey. Yet, it simultaneously possessed undeniable avian traits, most notably its exquisitely preserved, highly developed feathered wings. These feathers were not merely ornamental. Their asymmetrical veins, similar to those of modern flying birds, strongly suggest an aerodynamic function, pointing towards a life that, at least in part, involved aerial locomotion. This unique combination of ancestral and derived traits firmly establishes Archaeopteryx as one of the most important transitional fossils ever unearthed, a living testament to the evolutionary process in action. The study of Archaeopteryx remains a vibrant field, particularly concerning the fascinating question of how flight evolved. Scientists continue to meticulously analyze every detail of its anatomy to better understand its aerial capabilities. There's a spirited debate within the paleontological community. Some researchers propose that Archaeopteryx was capable of some form of powered flight, using its feathered wings to actively propel itself through the air. They point to the sophisticated feather structure and the general avian body plan as evidence. Conversely, others argue that its skeletal structure, which lacked the large, keeled sternum found in powerful flying birds, essential for anchoring strong flight muscles, indicates it was primarily a glider, soaring between trees or making short, controlled descents. This limited muscle power, despite the advanced feathers, suggests a more primitive form of flight, perhaps an early evolutionary step towards true aerial mastery. Each subsequent discovery of a new Archaeopteryx specimen, though rare, has incrementally added profound detail to our understanding of this creature, sometimes challenging, sometimes confirming earlier hypotheses. From the intricate articulation of its clawed fingers, which hint at arboreal habits, to the lightweight, hollow bones characteristic of modern birds, every fossilized remnant tells a critical part of the evolutionary narrative. It's a continuous story, etched in stone, documenting the incredible transition from formidable, ground-dwelling dinosaurs to the diverse and dynamic birds that dominate our skies today. Archaeopteryx remains a living, or rather, fossilized, laboratory for studying one of life's most transformative innovations, the gift of flight. Fact 44. Archaeopteryx is a remarkable prehistoric creature that provides scientists with critical insight into evolution. This fact explores the etymology and significance of its name. Its scientific name, Archaeopteryx lithographica, literally translates from ancient Greek as ancient wing from the lithographic stone. This nomenclature perfectly encapsulates its groundbreaking discovery and its dual nature. The ancient wing highlights its pivotal role as the earliest known feathered creature, clearly demonstrating avian characteristics, while lithographic stone refers to the fine-grained Solnhofen limestone quarries in Bavaria, Germany, where the first exquisitely preserved specimens were unearthed. These unique geological conditions allowed for the preservation of delicate structures like feathers, providing an unparalleled window into the past. Fact 45. Archaeopteryx is a remarkable prehistoric creature that provides scientists with critical insight into evolution. This fact explores the historical context of its initial discovery and its profound impact on scientific thought. The first complete skeleton of Archaeopteryx was found in 1861, just 2 years after Charles Darwin published On the Origin of Species. Its blend of reptilian teeth, long bony tail, clawed fingers, and avian feathers, wishbone features offered compelling, tangible evidence for the theory of evolution by natural selection and the concept of transitional forms. This discovery was a profound validation for Darwin's ideas, providing a missing link that beautifully illustrated the gradual evolutionary bridge between distinct animal groups. Its appearance ignited vigorous scientific debate and public fascination, firmly establishing Archaeopteryx as an icon of evolutionary biology. Fact 46. Archaeopteryx is a remarkable prehistoric creature that provides scientists with critical insight into evolution. This fact explores a key reptilian feature, its dentition. Unlike modern birds, which possess beaks and lack teeth, Archaeopteryx famously sported a set of small, sharp, conical teeth in both its upper and lower jaws. These teeth were distinctively socketed, much like those of many reptiles and non-avian dinosaurs, suggesting a carnivorous or insectivorous diet. The presence of these reptilian teeth, alongside its unmistakable feathers, highlighted its ancestral connection to dinosaurs and underscored the gradual loss of teeth as birds evolved, eventually replaced by the lighter, more versatile beak for feeding efficiency and flight adaptation. Fact 47. Archaeopteryx is a remarkable prehistoric creature that provides scientists with critical insight into evolution. This fact explores another significant reptilian characteristic, its long, bony tail. In stark contrast to the short, fused tailbones, pygostyle, of modern birds, which serve as an anchor for tail feathers and aid in steering during flight. Archaeopteryx possessed a lengthy, lizard-like tail composed of numerous individual vertebrae. Each vertebra along this extended tail bore a pair of feathers, implying it would have functioned more as a counterbalance or a primitive aerodynamic control surface rather than the sophisticated steering mechanism seen in extant birds. This robust, bony tail further cemented its link to theropod dinosaurs, whose elongated tails were crucial for balance and locomotion. Fact 48. Archaeopteryx is a remarkable prehistoric creature that provides scientists with critical insight into evolution. This fact explores its most iconic avian feature, its highly developed feathered wings. The fossil impressions of Archaeopteryx wings clearly show well-preserved, asymmetrical flight feathers, a key characteristic of feathers used for aerodynamic lift and propulsion in modern flying birds. This asymmetry, where the leading edge of the feather vane is narrower than the trailing edge, is crucial for generating lift. The existence of such advanced feathers, arranged in distinct wings, irrefutably demonstrated that Archaeopteryx was feathered not just for insulation, but for flight, or at least some form of aerial locomotion, making it a pivotal figure in understanding the evolution of flight. Fact 49. Archaeopteryx is a remarkable prehistoric creature that provides scientists with critical insight into evolution. This fact delves into the ongoing scientific debate regarding its flight capabilities. Was Archaeopteryx capable of sustained powered flight, or was it primarily a glider? Evidence for powered flight includes the asymmetrical flight feathers and the presence of a furcula, wishbone, which is associated with strong flight muscles. However, arguments for gliding or limited powered flight cite its relatively small sternum, breastbone, which lacked the deep keel found in modern birds that provides a large attachment surface for powerful pectoral muscles. This anatomical paradox fuels the debate, suggesting Archaeopteryx might have been an awkward flyer, perhaps taking off from elevated positions or engaging in short bursts of flapping. Fact 50. Archaeopteryx is a remarkable prehistoric creature that provides scientists with critical insight into evolution. This fact focuses on its skeletal structure and the implications for muscle power. While Archaeopteryx possessed beautifully aerodynamic feathers, its overall skeletal anatomy hints at limitations in muscular strength for powerful flight. The relatively flat, underdeveloped sternum, compared to the deep-keeled sternum, carina, of modern birds, indicates a restricted attachment area for the large flight muscles, pectorals, required for sustained flapping flight. This suggests that while it could likely generate some lift and perhaps short bursts of flight, it would have lacked the endurance and agility of true powered flyers. Its skeletal design points towards a transitional stage where feather morphology outpaced muscular development for aerial locomotion. Fact 51. Archaeopteryx is a remarkable prehistoric creature that provides scientists with critical insight into evolution. This fact explores its paleo-environment and habitat during the late Jurassic period. Approximately 150 million years ago, Archaeopteryx roamed what is now Europe, specifically a tropical archipelago environment in Bavaria, Germany. This region was characterized by shallow, warm lagoons dotted with small islands, bordered by coral reefs and low-lying vegetation. The exceptional preservation of Archaeopteryx fossils, along with myriad other marine and terrestrial organisms, in the fine-grained Solnhofen limestone indicates that many creatures, including Archaeopteryx, likely fell into these anoxic, oxygen-depleted, lagoon waters, which prevented decomposition and scavenging, thereby creating a pristine record of life in this ancient ecosystem. Fact 52. Archaeopteryx is a remarkable prehistoric creature that provides scientists with critical insight into evolution. This fact examines its distinctive clawed fingers, a prominent reptilian trait retained on its feathered wings. Unlike modern birds, whose wings are fused, lightweight structures primarily designed for flight, Archaeopteryx possessed 3 distinct, mobile fingers at the end of each wing, each tipped with a sharp, recurved claw. These claws suggest that Archaeopteryx may have used its wings not only for some form of aerial locomotion, but also for climbing trees or scrambling over rough terrain. This ability to grasp and climb would have been highly advantageous in its proposed arboreal, tree-dwelling, or scansorial, climbing, lifestyle potentially providing a launch platform for gliding or short flights. Fact 53. Archaeopteryx is a remarkable prehistoric creature that provides scientists with critical insight into evolution. This fact investigates the presence of lightweight, hollow bones, a crucial adaptation for flight found in modern birds. While not as extensively pneumatic, air-filled, as the bones of present-day avians, Archaeopteryx did exhibit some degree of bone lightness, suggesting an evolutionary trend towards reducing skeletal mass for aerial efficiency. This feature points towards the development of a more efficient respiratory system, possibly involving air sacs, a characteristic shared with its theropod dinosaur ancestors and a prerequisite for the high metabolic demands of flight. The gradual evolution of lightweight bones is a testament to the selective pressures favoring reduced weight for creatures exploring an airborne niche. Fact 54. Archaeopteryx is a remarkable prehistoric creature that provides scientists with critical insight into evolution. This fact explores the insights derived from studying its brain structure and sensory capabilities. Although direct brain tissue is not preserved, paleontologists can create endocasts, internal molds, of the brain case to infer brain shape and relative proportions of different brain regions. Studies of Archaeopteryx endocasts suggest it possessed enlarged optic lobes, indicative of sharp vision, which is essential for flight and hunting. Furthermore, its semicircular canals, crucial for balance and spatial orientation, were well developed, hinting at an adaptation for dynamic movement, possibly including aerial maneuvers. These sensory adaptations underscore its progression towards an avian lifestyle. Fact 55. Archaeopteryx is a remarkable prehistoric creature that provides scientists with critical insight into evolution. This fact delves into its likely dietary habits. Based on the presence of sharp, conical teeth and its overall body plan, Archaeopteryx is widely believed to have been a carnivore or insectivore. Its teeth would have been effective for grasping and processing small prey, such as insects, lizards, or other small vertebrates prevalent in its late Jurassic environment. This dietary niche aligns with what we understand about early birds and many small theropod dinosaurs. The ability to hunt and capture fast-moving prey, whether on the ground, in the trees, or even in the air, would have been a critical behavioral aspect driving its evolutionary development. Fact 56. Archaeopteryx is a remarkable prehistoric creature that provides scientists with critical insight into evolution. This fact explores its terrestrial locomotion and movement on the ground. While its winged form suggests aerial capabilities, Archaeopteryx would have spent a significant amount of time on the ground or in trees. Its hind limbs were well developed and bird-like in proportion, suggesting bipedal locomotion. However, the exact posture and gait on the ground are still debated. Some reconstructions depict it as a fast runner, much like its theropod relatives, while others suggest a more awkward, perhaps slow-moving gait, due to the structure of its pelvis and leg muscles. Understanding its terrestrial movement is crucial for piecing together its complete ecological niche and how it navigated its ancient world. Fact 57. Archaeopteryx is a remarkable prehistoric creature that provides scientists with critical insight into evolution. This fact highlights its crucial evolutionary relationship to theropod dinosaurs. Archaeopteryx provides some of the strongest evidence for the avian descent from feathered theropod dinosaurs. Its skeletal structure, apart from the feathers, bears striking similarities to small predatory dinosaurs like Compsognathus, which lived in the same environment. These shared features include a long bony tail, gastralia, belly ribs, teeth, and a specific ankle bone structure. This anatomical congruence firmly places Archaeopteryx not just as an early bird, but as a direct descendant of the theropod lineage, acting as a quintessential missing link that beautifully illustrates macroevolutionary change. Fact 58. Archaeopteryx is a remarkable prehistoric creature that provides scientists with critical insight into evolution. This fact specifically examines the asymmetry of its flight feathers. One of the most compelling pieces of evidence for Archaeopteryx's flight capability lies in the detailed impressions of its feathers. Crucially, these impressions reveal that its primary wing feathers were asymmetrical, meaning the leading edge of the feather vein was narrower and stiffer than the trailing edge. This asymmetry is a hallmark of modern aerodynamic flight feathers, designed to create lift and reduce drag. The presence of such advanced feather morphology, even if its skeletal muscle attachment was limited, signifies a strong evolutionary commitment to aerial locomotion and underscores its place as a true pioneer of flight. Fact 59. Archaeopteryx is a remarkable prehistoric creature that provides scientists with critical insight into evolution. This fact details how Archaeopteryx serves as foundational evidence for the theropod hypothesis of avian origins. This hypothesis posits that birds evolved directly from a lineage of small, feathered theropod dinosaurs. Archaeopteryx perfectly embodies this idea, showcasing a mosaic of reptilian traits, e.g., teeth, long bony tail, clawed fingers, alongside definitive avian features, e.g., feathers, furcula, possibly backward-pointing hallux. Its existence provides a clear morphological bridge, making it the poster child for the dinosaur-bird connection and a cornerstone in our understanding of evolutionary transitions from landbound predators to winged flyers. Fact 60. Archaeopteryx is a remarkable prehistoric creature that provides scientists with critical insight into evolution. This fact explores the variability and insights gained from different fossil specimens. To date, 12 skeletal specimens and a feather of Archaeopteryx have been discovered, each adding subtle yet significant details to our understanding. For instance, the first specimen, the London specimen, established its basic features, while the Berlin specimen, arguably the most famous, provided clearer details of the skull and feather impressions. Later discoveries, like the Maxberg or Solnhofen specimens, further clarified aspects of its skeletal anatomy, some showing variations in size or preservation that hint at individual differences within the species or even different growth stages. Each new find refines the scientific narrative, offering a more complete picture of this ancient flyer. Fact 61. Archaeopteryx is a remarkable prehistoric creature that provides scientists with critical insight into evolution. This fact investigates its relevance to the ground-up, cursorial versus trees-down, arboreal theories of flight evolution. Archaeopteryx plays a central role in both debates. The trees-down hypothesis suggests early birds evolved flight by gliding down from trees, using claws for climbing and feathers for controlled descent. The clawed fingers and potential arboreal adaptations of Archaeopteryx lend support to this. Conversely, the ground-up hypothesis proposes that flight evolved from ground-dwelling, bipedal dinosaurs using wing flapping to enhance running speed, catch prey, or gain elevation. While Archaeopteryx doesn't definitively settle the debate, its mosaic features allow for interpretations supporting aspects of both theories, showcasing the complexity of evolutionary pathways. Fact 62. Archaeopteryx is a remarkable prehistoric creature that provides scientists with critical insight into evolution. This fact highlights the presence of a furcula, or wishbone, in its skeletal structure. The furcula is a fused clavicle bone unique to birds and some theropod dinosaurs that plays a critical role in the flight apparatus, acting as a spring to store and release energy during the wing beat cycle. The discovery of a well-formed furcula in Archaeopteryx was a significant avian characteristic, strongly indicating its evolutionary trajectory towards flight. Its presence, alongside reptilian features, perfectly illustrates the incremental acquisition of bird-like adaptations that ultimately led to the sophisticated flight mechanisms of modern avians. Fact 63. Archaeopteryx is a remarkable prehistoric creature that provides scientists with critical insight into evolution. This fact examines the structure of its foot, particularly the hallux, reverse toe. In modern perching birds, the hallux is a backward-pointing toe that allows them to grasp branches. The presence and orientation of the hallux in Archaeopteryx have been subjects of debate. While some specimens show a partially reversed hallux, suggesting a limited perching ability, others indicate a more forward-pointing configuration, typical of ground-dwelling animals. This ambiguity provides further fuel for discussions about Archaeopteryx's lifestyle. Was it primarily arboreal, terrestrial, or capable of both? Its foot structure, like many of its features, reflects its transitional nature, not fully adapted to one specific niche, but blending traits from multiple modes of locomotion. Fact 64. Archaeopteryx is a remarkable prehistoric creature that provides scientists with critical insight into evolution. This fact explores the unique paleontological significance of the Solnhofen limestone. All known Archaeopteryx specimens have been discovered in the Upper Jurassic Solnhofen Formation of Bavaria, Germany. This site is renowned globally for its exceptional Lagerstätte preservation, meaning it contains fossils of extraordinary quality and completeness, often including soft tissues rarely preserved elsewhere. The fine-grained lithographic limestone, formed in ancient anoxic lagoons, created conditions perfect for capturing the intricate details of feathers and delicate bones. Without the specific geological conditions of Solnhofen, our understanding of Archaeopteryx and the crucial feather impressions might have been far less complete, profoundly altering our perspective on bird evolution. Fact 65. Archaeopteryx is a remarkable prehistoric creature that provides scientists with critical insight into evolution. This fact reflects on its enduring legacy in evolutionary science. More than 160 years after its initial discovery, Archaeopteryx remains one of the most studied and iconic fossils, continually shaping our understanding of macroevolutionary transitions. It stands as a powerful symbol of evolution in action, illustrating how a lineage of terrestrial dinosaurs gradually acquired the anatomical innovations required for aerial existence. Its mosaic of features continues to inspire research into flight mechanics, feather evolution, and the phylogenetic relationships between dinosaurs and birds, proving that this ancient wing is still a vibrant, fossilized laboratory for evolutionary discovery. However, critical analysis of its skeletal structure revealed inherent limitations in muscle power, a key constraint on its flight capabilities. Each subsequent discovery of a new specimen has only added more intricate detail to our ever-evolving understanding of this incredible creature. From its surprisingly clawed fingers to its delicate, lightweight bones, every anatomical feature of Archaeopteryx narrates a profound story about the evolutionary transition from ground-dwelling dinosaurs to the sophisticated flying birds we know today. Fact 66. Archaeopteryx, a truly remarkable prehistoric creature, stands as a cornerstone in our understanding of evolutionary biology, offering critical insights into the monumental transition from reptiles to birds. Discovered in 1861, just 2 years after Charles Darwin published On the Origin of Species, it immediately captured the world's attention as a powerful piece of evidence supporting his theories. This particular fact delves into its groundbreaking role as a missing link, revealing how its unique blend of traits unveiled an ancient evolutionary pathway. Living approximately 150 million years ago during the late Jurassic period in what is now present-day Europe, the first specimen of Archaeopteryx, known as the London specimen, was unearthed from the finely grained limestone deposits of Solnhofen, Germany. It presented an astonishing mosaic, a creature undeniably possessing reptilian characteristics like sharp, cone-shaped teeth set in its jaws, a long, bony tail typical of dinosaurs, and 3 clawed fingers on each wing. Yet, unequivocally, it also bore perfectly preserved, asymmetrical feathers structured for flight, along with a furcula, wishbone, characteristic of birds. These seemingly contradictory, yet harmoniously integrated features made Archaeopteryx an unparalleled transitional fossil, a tangible bridge between 2 vast classes of vertebrates. The ongoing study of Archaeopteryx specimens continues to fuel vibrant debates among paleontologists and evolutionary biologists about the origins of avian flight. Some researchers champion the view that Archaeopteryx, with its well-developed flight feathers and overall aerodynamic form, was capable of at least rudimentary powered flight, pushing the boundaries of its ancient aerial domain. Others contend that its skeletal structure, notably lacking a deep-keeled sternum for robust flight muscle attachment, points toward a primary role as a glider, perhaps launching from trees or elevated positions. Regardless of the exact mode of flight, its existence undeniably showcases an organism on the cusp of mastering the skies, a testament to the incremental adaptations that eventually led to the diverse avifauna we observe today. Fact 67. Expanding on the marvel of Archaeopteryx, This fact highlights the intricate duality of its anatomy, which flawlessly showcases both its dinosaurian heritage and its avian future. Its reptilian features were not merely rudimentary but clearly defined. A long, bony tail comprising numerous vertebrae, a stark contrast to the fused, stumpy pygostyle of modern birds. Its jaws were lined with small, sharp teeth, a characteristic shared with its carnivorous theropod ancestors but long lost in contemporary birds. Furthermore, the three distinct, clawed digits on each forelimb, while modified into wings, retained a flexibility and grasping ability reminiscent of a dinosaur's hand, possibly aiding in climbing or maneuvering. Conversely, its avian innovations were equally striking and revolutionary. The most prominent, of course, were the feathers. Unlike the proto-feathers found on many non-avian dinosaurs, Archaeopteryx possessed fully developed, asymmetrical flight feathers on its wings and tail, indicating a clear aerodynamic function. The presence of a furcula, or wishbone, formed by the fusion of two clavicles, was another definitive bird-like trait, crucial for bracing the shoulder girdle during the stresses of flight. This unique combination, a body plan essentially reptilian, adorned with undeniably avian integument and a key skeletal adaptation for flight, underscored its pivotal position in the grand evolutionary narrative. Each new Archaeopteryx fossil unearthed provides further granular detail, allowing scientists to meticulously reconstruct its form and function. From the subtle curvatures of its clawed fingers, suggesting a propensity for perching or climbing, to the finely tuned architecture of its lightweight, hollowed bones that reduced its overall mass, every fragment contributes to a richer understanding. These discoveries collectively tell a compelling story of evolutionary innovation, meticulously charting the biological steps involved in the breathtaking transition from heavy, ground-dwelling dinosaurs to the agile, aerial mastery of birds. Fact 68. The exceptional preservation of Archaeopteryx fossils is not merely a stroke of luck, but a direct consequence of its unique late Jurassic habitat, the ancient Solnhofen lagoons of what is now Bavaria, Germany. This fact explores how these tranquil, oxygen-poor marine environments served as an unparalleled natural laboratory, encapsulating life from 150 million years ago with astonishing fidelity. The fine-grained, anoxic, lacking oxygen, limestone sediments prevented scavenging and decomposition, allowing delicate structures like feathers and even soft tissues to be fossilized in exquisite detail. The Solnhofen environment was a shallow, subtropical sea dotted with small, arid islands. Archaeopteryx, likely an inhabitant of these islands, might have fallen into the lagoons after death or been blown in during storms. This specific taphonomy, the study of how organisms decay and become fossilized, has been crucial to our understanding, providing not just bones, but also clear impressions of its feathers, which are vital for reconstructing its flight capabilities. Without these rare conditions, Archaeopteryx might have remained just another fragment of bone, devoid of the very features that define its evolutionary significance. As each new specimen emerges from these historic quarries, scientists gain ever more profound insights into the physiology and behavior of this prehistoric icon. The delicate structure of its lightweight bones, hinting at the efficiency required for aerial locomotion, combined with the clear imprints of its advanced feathers, paints a vivid picture of an animal caught between worlds. Every claw, every feather impression, every subtle skeletal curve meticulously documented contributes to the epic narrative of Archaeopteryx's journey from its dinosaurian roots to the pioneering role it played in the development of flight. Fact 69. While Archaeopteryx's status as a feathered dinosaur bridging the evolutionary gap to birds is undeniable, the precise nature of its flight capabilities remains a subject of intense scientific debate. This fact delves into the contrasting theories surrounding whether it was capable of true powered flight, akin to modern birds, or if its aerial excursions were primarily restricted to gliding. The answer holds profound implications for understanding the initial stages of avian evolution. Proponents of powered flight point to the clear asymmetry of its primary flight feathers, a characteristic almost universally found in birds capable of active flapping. They argue that while its skeletal features might seem primitive, a combination of strong musculature, perhaps not fully represented by current fossil interpretations, and effective wing movements could have allowed for rudimentary flapping flight over short distances or between trees. Conversely, the argument for gliding emphasizes the absence of a prominent, keeled sternum, the anchor point for powerful flight muscles in modern birds, and the relatively small size of its pectoral girdle. This camp suggests Archaeopteryx likely launched itself from elevated positions, using its wings more as elaborate parachutes or hang gliders, perhaps only occasionally employing shallow, inefficient flapping. Each discovery of a new specimen, often revealing subtle differences in skeletal robustness or feather morphology, adds complexity to this ongoing discussion. From the length and curvature of its clawed fingers, which some interpret as ideal for climbing trees, a prerequisite for a glidden lifestyle, to the inferred strength of its lightweight, hollow bones, the evidence is meticulously scrutinized. Every physical attribute of Archaeopteryx contributes a piece to the larger puzzle, allowing scientists to piece together a dynamic story about the incremental adaptations that transformed a ground-dwelling dinosaur into a creature capable of exploring the skies, even if that exploration began with tentative glides rather than powerful ascents. Fact 70. A key to understanding Archaeopteryx's aerial ambitions lies within the intricate structure of its feathers, a marvel of biological engineering that this fact explores in detail. Unlike the simpler, filamentous protofeathers found on some other dinosaurs, Archaeopteryx possessed contour feathers with distinct central shafts, veins composed of barbs, and barbules that interlock to form a continuous, aerodynamic surface. Crucially, its flight feathers exhibited a distinct asymmetry, with a narrower leading edge and a broader trailing edge, a classic adaptation for generating lift and thrust during flight. This advanced feather structure strongly suggests an aerodynamic function, indicating Archaeopteryx was designed to interact with the air in a controlled manner. The interlocking barbules would have created a stiff, efficient airfoil, capable of resisting air pressure and minimizing drag. However, the exact mechanics of how these feathers were powered remained contentious. While the feathers themselves were clearly ready for flight, the underlying skeletal framework, particularly the relatively flat sternum, without the deep keel seen in modern flying birds, still points to a limitation in the powerful musculature required for sustained, active flapping. Every new fossil discovery further illuminates the nuances of Archaeopteryx's feathering. From the fossilized imprints that reveal their precise arrangement and shape on the wings and tail, to insights gleaned about the robustness of the feather quills themselves, scientists continuously refine their models of its flight. Whether its clawed fingers were used for climbing to launch points, or its lightweight bones provided sufficient agility, every detail gleaned from these ancient fossils contributes to the grand narrative, deepening our comprehension of how the sophisticated mechanics of flight evolved, bit by feathered bit, from its dinosaurian predecessors to its eventual avian descendants. Fact 71. Beyond its iconic feathers, the internal scaffolding of Archaeopteryx, its skeletal structure, offers a profound glimpse into the fundamental changes that enabled the evolution of flight. This fact delves into the specific adaptations of its bones, revealing a remarkable blend of reptilian robustness and avian lightness, crucial for understanding its unique position in the evolutionary tree. While its bones were not as extensively hollowed and pneumaticized, filled with air sacs, as those of modern birds, they exhibited a reduction in density compared to typical dinosaurs, a clear step toward minimizing weight for aerial locomotion. Its vertebral column, especially the long, bony tail, still bore the hallmarks of its dinosaurian ancestry, providing balance but adding significant mass. However, innovations like the presence of a furcula, wishbone, though simpler than in later birds, provided a spring-like mechanism to brace the shoulders during wing movements, a vital adaptation for flight. The architecture of its shoulder girdle and sternum, while indicating limited muscle power compared to powerful flyers, was clearly adapted to support some form of aerial activity, whether gliding or weak flapping. Each discovery of a new specimen allows paleontologists to meticulously map these skeletal transitions. From the finely preserved outlines of its clawed fingers, hinting at a tree-climbing lifestyle that could precede flight, to the internal structure of its lightweight bones, visible through advanced imaging techniques. Every detail enriches our understanding. These fossils are not just static remnants. They are dynamic blueprints, each part of Archaeopteryx telling a vivid story about the incremental evolutionary modifications that transformed a heavy, ground-dwelling dinosaur into a creature gracefully navigating the ancient skies, balancing strength with the imperative of weight reduction. Fact 72. A central enigma surrounding Archaeopteryx pertains to the precise mechanism by which avian flight evolved. This fact explores the two dominant hypotheses, the ground-up, cursorial, theory and the trees-down, arboreal, theory, and how Archaeopteryx provides crucial, yet sometimes conflicting, evidence for each. The cursorial theory suggests that flight evolved in ground-dwelling, bipedal dinosaurs that used their feathered forelimbs for running, leaping, and eventually flapping to gain lift, perhaps to capture prey or escape predators. Conversely, the arboreal theory proposes that flight originated in tree-dwelling ancestors who developed feathers and wings to aid in gliding from branch to branch, eventually leading to active flapping. Archaeopteryx presents features that support both views. Its strong legs and clawed feet could suggest ground-dwelling or perching ability, while its distinct flight feathers and overall aerodynamic form lend credence to an aerial lifestyle. The debate often centers on whether its clawed fingers were primarily for climbing or for grasping prey, and whether its limited muscle power was sufficient for launching from the ground or better suited for controlled descents. Every new specimen discovery brings fresh data to this long-standing scientific discussion. From the detailed morphology of its clawed fingers, which might suggest arboreal adaptation, to the insights gained from its lightweight bones regarding its overall agility and potential for terrestrial locomotion, scientists continuously re-evaluate the evidence. Each part of Archaeopteryx holds clues, collectively weaving a complex story about the step-by-step evolutionary transition that transformed ground-dwelling dinosaurs into airborne birds, possibly through a dynamic interplay of both arboreal and cursorial behaviors. Fact 73. The study of Archaeopteryx, while incredibly enlightening, is not without its significant challenges, making every interpretative step a rigorous scientific endeavor. This fact highlights some of the primary difficulties faced by paleontologists, from the rarity of well-preserved specimens to the inherent ambiguities in interpreting fossilized data. Archaeopteryx fossils are among the rarest and most valuable in the world, with only a dozen known specimens, each presenting unique features and preservation states. This scarcity means that every piece of evidence must be meticulously analyzed and cross-referenced. Furthermore, the process of fossilization itself can introduce distortions. Bones can be crushed or shifted, making accurate reconstruction of the original skeletal arrangement difficult. Distinguishing between genuine anatomical features and artifacts of preservation requires keen expertise. The interpretation of muscle attachment sites, crucial for estimating flight capabilities, is also inferential, as soft tissues rarely fossilize. Scientists rely on comparative anatomy with modern birds and other dinosaurs, but Archaeopteryx's unique transitional status means there's often no perfect living analog. Despite these hurdles, each discovery of a new specimen invariably adds more critical detail to our understanding of this creature. From the subtle curvatures of its clawed fingers, indicating specific ranges of motion, to the microscopic analysis of its lightweight bones, revealing growth patterns and metabolic rates, every fragment contributes to a clearer picture. Every part of Archaeopteryx serves as a meticulously preserved chapter in an ancient story, revealing the complex, sometimes ambiguous, transition from ground-dwelling dinosaurs to flying birds and continuously pushing the boundaries of scientific inquiry. Fact 74. The estimated size and weight of Archaeopteryx are crucial parameters when assessing its potential for flight, and this fact explores how these factors influence scientific hypotheses about its aerial prowess. Typically, Archaeopteryx was about the size of a raven or a crow, measuring around 50 centimeters, 20 inches, in length, including its long tail, and weighing an estimated 0.8 to 1 kilogram, 1.8 to 2 pounds. This relatively small body size is a fundamental adaptation for flight, as reducing mass is paramount for overcoming gravity. Its compact dimensions, combined with its lightweight, partially hollowed bones, would have kept its wing loading, body weight divided by wing area, within a range potentially conducive to flight, even if not highly efficient. A smaller creature generally requires less power to achieve lift and sustained flight compared to larger animals. However, even at this size, the debate persists. Was it small enough for powered flight given its limited muscle attachment, or was its size more optimal for efficient gliding, allowing it to take advantage of air currents or short descents? Each new discovery of a specimen allows scientists to refine these size and weight estimates, often through sophisticated photogrammetry and 3D modeling. From analyzing the robusticity of its clawed fingers, which might indicate a lifestyle requiring climbing, and thus specific body proportions, to studying the internal architecture of its lightweight bones, every anatomical nuance provides clues. Each part of Archaeopteryx meticulously details a dynamic story, showcasing how fundamental physical attributes like size and weight played a critical role in the complex evolutionary transition from ground-dwelling dinosaurs to the lightweight, agile forms of flying birds. Fact 75. Archaeopteryx provides invaluable evidence for understanding the gradual evolution of the bird wing itself, transforming a dinosaurian forelimb into a sophisticated aerodynamic surface. This fact details how its wing structure represents an intermediate stage, possessing elements of both its reptilian heritage and its future avian specialization. Unlike the highly fused and rigid wing of modern birds, Archaeopteryx retained a much more flexible and less specialized forelimb, with 3 distinct, clawed fingers at the tips of its wings. These unfused digits, while still supporting flight feathers, indicate that the hand part of the wing had not yet fully committed to the role of a stiff, unitary airfoil. This flexibility might have allowed Archaeopteryx to climb trees using its claws or to manipulate objects, functionalities that modern birds have largely lost. The arrangement of its feathers, while clearly designed for flight, were attached directly to the bones of the forelimb, a basic arrangement that would later evolve into the complex musculature and tendon system that allows modern birds intricate control over each feather. Every new specimen discovery sheds more light on the evolutionary steps involved in this incredible transformation. From the precise articulation of its clawed fingers, providing insights into their range of motion and potential grasping ability, to the microstructure of its lightweight bones that supported its nascent wings, every detail contributes to a richer narrative. Each part of Archaeopteryx tells a compelling story about the incremental changes that molded a ground-dwelling dinosaur's arm into the powerful and precise flying apparatus of birds, highlighting the adaptive genius of evolution. Fact 76. The furcula, commonly known as the wishbone, is a defining skeletal feature of birds, playing a critical role in the mechanics of flight by bracing the shoulder girdle against the powerful forces generated during flapping. This fact specifically examines the presence and characteristics of the furcula in Archaeopteryx, highlighting its importance as a clear avian trait within a largely reptilian body plan. Unlike the separate clavicles, collarbones, found in most dinosaurs, Archaeopteryx possessed a fused furcula, albeit one that was relatively slender and V-shaped compared to the more robust, U-shaped furculae of modern birds. The presence of a furcula in Archaeopteryx is a strong indicator of its avian affinities and its capability for some form of aerial locomotion. This bone acts as a spring, storing and releasing energy during the flight stroke, contributing to the efficiency of flapping. While its slender nature suggests that Archaeopteryx's flight muscles may not have been as powerful or its flight as sustained as modern birds, the very existence of this structure confirms its evolutionary trajectory towards true avian flight. It represents a crucial step in the development of the complex, integrated skeletal system necessary for efficient movement through the air. Each discovery of a new specimen offers further opportunities to examine the subtle variations and robusticity of this vital bone. From how it articulates with the shoulder blades, providing insights into the range of wing motion, to its structural integrity in context with its lightweight bones and clawed fingers, every detail is scrutinized. Every part of Archaeopteryx contributes to a detailed story about the specific skeletal innovations that facilitated the transition from ground-dwelling dinosaurs to flying birds, underscoring the functional evolution of each anatomical component for aerial existence. Fact 77. The feet of Archaeopteryx offer another fascinating glimpse into its transitional lifestyle, suggesting adaptations for both terrestrial movement and possibly arboreal perching. This fact explores the morphology of its feet, contrasting them with those of its dinosaurian ancestors and modern birds, and inferring potential behaviors. Its feet were generally bird-like in their overall structure, with 4 toes, 3 pointing forward and 1 pointing backward, the hallux. This arrangement is characteristic of perching birds, allowing them to grasp branches effectively. However, the claws on its toes were relatively long and curved, resembling those of climbing birds or even some terrestrial raptors. This dual morphology has led to varied interpretations. Some paleontologists suggest its feet were well suited for climbing trees, supporting the arboreal origin of flight theory, while others argue they were also robust enough for moving across the ground, hinting at a more versatile lifestyle. The debate around its foot structure ties directly into understanding its primary habitat and how it might have launched itself into the air. Each discovery of a new specimen, particularly those with well-preserved foot bones, adds more precise detail to these interpretations. From the precise articulation of its clawed fingers on its forelimbs, which might have aided in climbing, to the inferred strength of its lightweight bones, contributing to overall agility, every feature is meticulously analyzed. Every part of Archaeopteryx thus tells a complex story about the intricate adaptations that enabled the transition from ground-dwelling dinosaurs to flying birds, balancing terrestrial agility with nascent aerial capabilities. Fact 78. To truly appreciate the evolutionary significance of Archaeopteryx, it's crucial to place it within the broader context of other feathered dinosaurs and early birds that have been discovered since its initial unearthing. This fact compares Archaeopteryx with contemporaries and near-contemporaries, such as Anchiornis and Microraptor, highlighting how these discoveries have refined our understanding of avian origins. While Archaeopteryx was once considered unique, the discovery of numerous paravian dinosaurs with feathers, some even showing early flight adaptations, has created a richer tapestry of early avian evolution. For instance, Microraptor, a small, 4-winged dromaeosaurid from the early Cretaceous, possessed flight feathers on all 4 limbs, suggesting a gliding lifestyle that might represent an alternative evolutionary pathway or an earlier stage of flight development. Anchiornis, another feathered paravian from the late Jurassic, predates Archaeopteryx and also bore feathers on its limbs and tail, indicating that feathering was widespread among these dinosaur groups long before true flight. These comparisons underscore that Archaeopteryx was not an isolated evolutionary leap, but part of a wider, more complex radiation of feathered creatures experimenting with different modes of aerial locomotion. Each new discovery of a specimen, whether it's another Archaeopteryx or a related feathered dinosaur, continually adds more detail to this intricate evolutionary tree. From the structure of its clawed fingers, which can be compared to the grasping digits of other arboreal or climbing feathered dinosaurs, to the lightweight bones common among these early aerialists, every fossil helps clarify phylogenetic relationships. Every part of Archaeopteryx, thus, tells a more nuanced story about the transition from ground-dwelling dinosaurs to flying birds, revealing a dynamic period of evolutionary experimentation. Fact 79. A fascinating and often debated aspect of Archaeopteryx's biology is its metabolic rate and whether it was endothermic, warm-blooded, like modern birds, or ectothermic, cold-blooded, like most reptiles. This fact explores the evidence and implications of its potential thermoregulation, which would have had significant consequences for its activity levels and flight capabilities. While direct evidence of metabolism is rare in fossils, scientists infer it from skeletal features, growth rates, and behavioral patterns. Modern birds are highly active, endothermic creatures with high metabolic rates, which provide the sustained energy needed for powered flight. Archaeopteryx's status as a transitional form makes its thermoregulation particularly intriguing. Some studies, Analyzing its bone microstructure and growth rings suggests a faster growth rate than typical reptiles, hinting at a more elevated metabolism. Its feathers, primarily for flight, would also have provided excellent insulation, supporting the idea of endothermy by helping to retain body heat. However, arguments for a lower metabolic rate exist, based on its more primitive skeletal features and presumed less energetic flight. Each discovery of a new specimen, particularly those allowing for microscopic bone analysis, adds more detail to this complex picture. From the presence of vascular canals in its lightweight bones, indicating active bone remodeling, a sign of higher metabolism, to the robusticity of its clawed fingers, which might suggest bursts of activity for hunting, every feature is scrutinized. Each part of Archaeopteryx helps tell a deeper story about the physiological adaptations that underpin the transition from ground-dwelling dinosaurs to flying birds, including the fundamental shift in metabolic strategies necessary for an aerial lifestyle. Fact 80. The theropod hypothesis, which posits that birds evolved directly from small, carnivorous theropod dinosaurs, finds one of its most compelling champions in Archaeopteryx. This fact delves into how the fossil's skeletal similarities to these predatory dinosaurs cemented its role as a key piece of evidence for this evolutionary link. Before Archaeopteryx, the connection between dinosaurs and birds was largely theoretical. Its discovery provided tangible proof. Archaeopteryx shares numerous skeletal characteristics with small theropods like Compsognathus or Velociraptor, though Velociraptor was discovered much later. These include the structure of its pelvis, hind limbs, skull, especially the large eye sockets, and the presence of serrated teeth. The overall body plan, particularly the three-fingered hand, albeit modified into a wing, is also strikingly similar to theropod forelimbs. These shared features provided strong morphological evidence that birds were indeed direct descendants of dinosaurs, rather than evolving from a separate, more primitive reptilian lineage. Each discovery of a new specimen further strengthens these phylogenetic connections. From the detailed morphology of its clawed fingers, which are clearly homologous to the digits of theropod hands, to the lightweight bones that are a common feature among advanced theropods, every anatomical detail reinforces this lineage. Every part of Archaeopteryx tells an undeniable story about the direct evolutionary transition from agile, ground-dwelling theropod dinosaurs to the specialized forms of flying birds, fundamentally reshaping our understanding of avian ancestry. Fact 81. The study of Archaeopteryx has been profoundly enriched by the discovery of multiple distinct specimens, each offering unique insights and sometimes subtle variations that inform our understanding. This fact emphasizes the significance of having a diverse fossil record for this creature, illustrating how each new find contributes a critical piece to the overall paleontological puzzle. While the first specimen, the feathered fossil, and the London specimen revealed its crucial feathers, later finds brought other details to light. Some specimens show clearer impressions of the skull, revealing more about its brain size and sensory organs. Others provide better preservation of the foot bones, shedding light on its perching or terrestrial locomotion. Critically, variations observed between specimens, such as differences in bone robusticity or feather details, can help scientists understand individual variation within the species, potential sexual dimorphism, or even different stages of growth, providing a more dynamic view of Archaeopteryx than a single fossil ever could. Each discovery, regardless of its completeness, invariably adds more nuanced detail to our scientific understanding of this creature. From the subtle differences in the length and curvature of its clawed fingers, suggesting potential individual adaptations, to the precise structure of its lightweight bones, offering insights into its growth and development. Every part is meticulously analyzed. Each specimen of Archaeopteryx tells a slightly different but equally vital chapter in the comprehensive story about the transition from ground-dwelling dinosaurs to flying birds, collectively painting a vibrant portrait of ancient evolution. Fact 82. The enduring impact of Archaeopteryx extends far beyond academic circles. It has played a significant role in shaping public perception of evolution and the interconnectedness of life. This fact explores how this iconic fossil has served as a powerful, tangible symbol of transitional forms, making complex evolutionary concepts more accessible and understandable to a wider audience. Its dramatic combination of reptilian teeth and tail with avian feathers and wings provides an immediate, visceral illustration of evolution in action. For many, Archaeopteryx represents the quintessential missing link, a term that, while perhaps scientifically oversimplified, perfectly captures its role as a bridge between two major animal groups. Its image is frequently used in textbooks, museums, and documentaries to explain concepts like common descent, natural selection, and the gradual accumulation of adaptive traits. Its powerful visual evidence helped popularize the idea that birds are, in fact, living dinosaurs, a concept that was revolutionary at the time of its discovery and continues to fascinate. Each new discovery of a specimen only solidifies its iconic status, adding more intricate details to its already compelling narrative. From the fossilized remnants of its clawed fingers, evoking its dinosaurian past, to the delicate impressions of its feathers, promising an aerial future, every element resonates with the public imagination. Every part of Archaeopteryx tells a captivating story about the transition from ground-dwelling dinosaurs to flying birds, serving as a powerful, accessible testament to the transformative power of evolution. Fact 83. Modern scientific advancements have revolutionized the study of Archaeopteryx, allowing paleontologists to uncover hidden details far beyond what was possible with traditional examination. This fact explores the application of cutting-edge technologies, such as CT scans and synchrotron radiation, in analyzing these precious fossils, revealing insights previously unattainable. These non-invasive techniques allow scientists to see inside the rock without damaging the specimen, unlocking new layers of information. CT, computed tomography, scans create detailed 3D models of the bones, revealing their internal structure, muscle attachment sites, and pneumaticity, air sacs, with unprecedented clarity. This helps in more accurately reconstructing the skeleton and assessing its biomechanical properties for flight. Synchrotron radiation, an even more powerful X-ray imaging technique, can detect chemical compositions and elemental traces within the fossil and surrounding rock matrix, potentially identifying remnants of original soft tissues, pigments, or feather structures that are otherwise invisible. These technologies are providing crucial data to resolve long-standing debates about its diet, metabolism, and precise flight mechanics. Each discovery of a new specimen now benefits immensely from these technological tools, adding layers of detailed information. From the subtle internal structure of its clawed fingers, revealing their true strength and range of motion, to the microscopic analysis of its lightweight bones, identifying growth patterns or disease, every part contributes to a hyper-detailed understanding. Every aspect of Archaeopteryx thus continues to tell an ever more precise story about the transition from ground-dwelling dinosaurs to flying birds, with technology serving as the ultimate guide to its ancient secrets. Fact 84. The precise phylogenetic placement of Archaeopteryx within the broader dinosaur family tree, particularly among the paravs, the group encompassing birds and their closest non-avian dinosaur relatives, is a dynamic area of research. This fact delves into how its position defines our understanding of the avian lineage, constantly being refined by new fossil discoveries and analytical techniques. While universally accepted as a bird, Aviale, its exact relationship to other early avian groups or feathered dinosaurs is debated. Some cladistic analyses place Archaeopteryx as the most basal, earliest diverging member of Aviale, making it directly ancestral to all later birds. Other studies suggest it might be an early offshoot or a close relative of the lineage that led to modern birds, rather than a direct ancestor itself. This distinction is crucial for understanding whether Archaeopteryx represents the first bird, or simply one of many feathered paravians experimenting with flight. The discovery of older, more bird-like forms, or newer feathered dinosaurs with even more advanced flight adaptations, consistently challenges and refines its exact spot on the evolutionary tree. Each discovery of a new specimen provides valuable data points for these phylogenetic analyses. From the minute details of its clawed fingers, offering comparison points with other grasping or climbing paravians, to the intricate structure of its lightweight bones, which can be compared to similar adaptations in other early flyers. Every feature is crucial. Every part of Archaeopteryx helps to tell a clearer story about the complex branching and evolutionary transitions from ground-dwelling dinosaurs to flying birds, illustrating the intricate web of life that led to avian diversity. Fact 85. The extraordinary preservation of Archaeopteryx's delicate features, particularly its feathers, is a testament to a remarkable process of fossilization. This fact explores the specific conditions present in the Solnhofen limestone deposits that allowed for such exquisite detail, making these fossils invaluable windows into deep time. The area was once a shallow, subtropical lagoon system with exceptionally calm waters and anoxic, oxygen-depleted, bottom conditions. When an Archaeopteryx specimen died and settled on the lagoon floor, the lack of oxygen prevented scavenging bacteria and other decomposers from breaking down its soft tissues, including the feathers. The fine-grained calcium carbonate mud quickly enveloped the carcass, creating an airtight seal. Over millions of years, as layers of sediment accumulated and compacted, the organic material of the feathers slowly decayed, leaving behind perfect impressions in the lithified limestone. This rare combination of swift burial, anoxia, and fine sediment enabled the fossilization of features typically lost to time, providing unparalleled insights into Archaeopteryx's biology. Each new specimen unearthed from these unique deposits continues to add more precise detail to our understanding of this creature. From the remarkably preserved imprints of its clawed fingers, hinting at its fine motor skills, to the visible cellular structures within its lightweight bones, offering clues about its biology, every fossil is a treasure trove. Every part of Archaeopteryx tells an incredibly detailed story about the transition from ground-dwelling dinosaurs to flying birds, made possible by the serendipitous alchemy of ancient geological processes. Fact 86. A striking reptilian feature retained by Archaeopteryx was its dentition, a mouth full of small, sharp teeth, a characteristic that this fact examines for its evolutionary significance and implications for the creature's diet. Unlike modern birds, which possess keratinous beaks adapted for various feeding strategies, Archaeopteryx had a jawline equipped with individual, conical, non-serrated teeth set in sockets. This is a classic dinosaurian trait, firmly linking it to its theropod ancestors. The presence of teeth suggests a diet that likely involved catching and processing small prey, such as insects, lizards, or even small fish, prevalent in its lagoonal environment. The size and shape of its teeth indicate a generalist carnivorous or insectivorous diet, requiring minimal chewing but effective grasping and tearing. The subsequent evolutionary loss of teeth in later bird lineages is a significant adaptation, leading to lighter skulls and the development of specialized beaks, but Archaeopteryx's dental structure provides a crucial snapshot of this transition before tooth loss became widespread in avian evolution. Each discovery of a new specimen, particularly those with well-preserved skull and jaw structures, adds more detail to our understanding of its feeding ecology. From the potential use of its clawed fingers to manipulate prey, to the lightweight bones supporting its agile head movements, every anatomical detail provides clues. Every part of Archaeopteryx tells a compelling story about the transition from ground-dwelling dinosaurs to flying birds, meticulously detailing how even seemingly minor features like teeth underwent profound evolutionary changes to support an aerial lifestyle. Fact 87. Archaeopteryx's skeletal structure, while primitive in some respects, also hints at the early stages of skeletal pneumaticity, the presence of air sacs within bones, a critical adaptation for both weight reduction and respiratory efficiency in modern birds. This fact explores the subtle evidence for this feature in Archaeopteryx and its implications for its physiology and flight. While its bones were not as extensively hollowed as those of later birds, some studies suggest that certain elements, particularly in the vertebral column, showed early signs of pneumaticity. Skeletal pneumaticity is directly linked to the avian respiratory system, where air sacs extend into bones, reducing mass and contributing to the highly efficient unidirectional airflow through the lungs. The earliest signs of this in Archaeopteryx indicate that the evolution of such a system was already underway, even if not fully developed. This suggests that the advantages of weight reduction for flight and potentially an enhanced respiratory capacity for sustained activity were emerging well before birds achieved the remarkable aerial prowess seen in their modern descendants. Each discovery of a new specimen, especially when analyzed with advanced imaging techniques like CT scans, adds more precise detail to our understanding of its internal bone structure. From the robusticity and curvature of its clawed fingers, which might suggest a more terrestrial or arboreal lifestyle demanding sturdy limbs, to the microscopic analysis of its lightweight bones, revealing subtle signs of internal air pockets. Every part contributes to a deeper understanding. Every aspect of Archaeopteryx tells an intricate story about the physiological and structural adaptations that drove the transition from ground-dwelling dinosaurs to flying birds, including the unseen, internal evolution of its skeletal system. T.S. Every part contributes to a deeper understanding. Every aspect of Archaeopteryx tells an intricate story about the physiological and structural adaptations that drove the transition from ground-dwelling dinosaurs to flying birds, including the unseen, internal evolution of its skeletal system. Its unique mosaic of features firmly establishes it as arguably the most important transitional fossil ever discovered, a cornerstone in our understanding of macroevolutionary change. Archaeopteryx, a truly remarkable prehistoric creature, continues to provide scientists with critical and multifaceted insights into the grand narrative of evolution. It existed during the late Jurassic period, approximately 150 million years ago, in what is now modern-day Europe, a world vastly different from today, characterized by warm climates and extensive shallow seas. Its enduring scientific significance stems from the extraordinary blend of reptilian and avian characteristics it possessed, offering an unparalleled glimpse into the evolutionary pathway between two distinct vertebrate groups. Among its most striking features were reptilian traits such as sharp teeth, a long, bony tail, and clawed fingers on its wings, reminiscent of its theropod dinosaur ancestors. Simultaneously, it showcased definitively avian features, most notably its highly developed, asymmetrical feathers, which are structurally identical to those found on modern flying birds. These advanced feathers, clearly designed for aerodynamic function, suggest a capacity for flight. However, the exact nature of this flight remains a subject of intense scientific debate. Scientists continue to meticulously study Archaeopteryx to better unravel the intricate stages through which powered flight evolved. While its sophisticated feathers strongly imply airborne locomotion, its skeletal structure presents a more ambiguous picture. Certain aspects, such as a relatively flat sternum, breastbone, lacking a prominent keel, suggest limited muscle power compared to modern birds capable of strong, sustained flight. This has led to two primary schools of thought. Some paleontologists believe Archaeopteryx was capable of some form of powered flight, perhaps for short bursts or takeoff, while others argue it was primarily an arboreal or terrestrial glider, relying on its wings more for leaping or controlled descent. Each subsequent discovery of a new Archaeopteryx specimen has been a landmark event, adding invaluable detail and often reshaping our understanding of this enigmatic creature. From the nuanced structure of its clawed digits, suggesting climbing capabilities, to the intricate details of its hollow, lightweight bones, which hint at adaptations for reduced weight, every fossilized remnant tells a vital part of the story. Collectively, these individual facts illuminate the profound biological journey, piece by painstaking piece, detailing the transition from ground-dwelling, bipedal dinosaurs to the agile, aerial birds that populate our skies today, continuously reaffirming Archaeopteryx's unparalleled role in evolutionary biology. And that brings us to the end of today's journey into the world of Archaeopteryx, a creature that tells one of the most incredible stories in evolution. From its feathered wings to its dinosaur-like teeth and tail, it truly reminds us how nature evolves in the most unexpected ways. So what do you think? Does Archaeopteryx change the way you see birds or evolution? Let us know your thoughts in the comments. We always enjoy reading what you feel and think after each episode. And if you enjoyed this video, don't forget to subscribe to 100 Sleepy Facts for more relaxing and fascinating stories, and leave a comment to share your impressions. Until next time, Stay curious, stay relaxed, and sleep well.